It's Sci time for grade 6 students. These days we are talking about the heat and its effects lesson. And here's today's plan. There are 4 subtopics to be discussed, and first one, heat generation, already we have completed. And today we hope to discuss 9.2 effects of heat. This is today's plan. Let's move on to the effects of heat. There are 3 main effects of heat. First one is this. When heat changes, it changes the temperature. So that is the first change or the first effect of the heat. Second thing is this. We will discuss this in more details today. When the heat increases, the liquid gets expanded. So their size can increase. That is the second effect. Change in the size and or the shape of the body. Second effect of the heat. Third effect of heat is this. When heat increases, the state of matter can be changed. Solid to liquid or liquid to gas. In hot, medium or in hot conditions, it converts to gas. In cold conditions, that becomes solid. Change of a state of matter. And today mainly we will discuss about this change in the size of a body. Right, let's move on to that part. Expansion and contraction. Here there is some amount of water filled in this vessel. Temperature stays low, and when we heat this up, what happens? When heating this, the volume increases or the size of the material increases. This is described as the expansion. Remember the term expansion. Expansion means substance get bigger or expand when they are heated up. Again, if I cool this down, cooling it, again that will come back to the previous size or the volume. This is the reduction of the size, so reducing size of matter when cooling. That is the contraction, opposite of the expansion. Contraction. Substances get smaller or contract when they are cooled down. And we can experience or we can just experiment the expansion and contraction today. Mainly we will study 3 modes of this expansion. One is the solid expansion, liquid expansion, solid expansion, liquid expansion, and gas expansion. Again, in the same things, the solid, liquid or gases contract also. Right, next one, the activity number 2. This is in page number 3. You can see that the solid expansion. Let's play the video, and while video is playing, I'll explain it. So for this activity, we will take a marble or a glass ball and a ring. This ring is just smaller than the marble. Marble doesn't pass through the ring. And also we need a Bunsen burner and a beaker of water. The first step, we try to pass this marble through the ring. It doesn't pass. Then we heat the ring. Metal ring is heated up. Heating the metal ring. Again, we try to pass it. You can see it's passing through the ring. See that? Yes. The marble now passed through the ring. Like this. Now we put it in water and cool down. This time it doesn't pass. And expansion, contraction. Let's describe what has happened here. When we heat up the ring, it was get bigger, or the size increased. That's why the marble passed through this. Through the metal ring, the marble was passed through this one, because when we put that marble through that one, as its size increased, that is the expansion. Again, once we put it in water, it cools down, it contracted. Therefore, marble did not pass hereafter. So that is the activity number 2. The conclusion is solid get expand and contract. Activity number, this is not the activity, actually this is given in the tube as kind of a application of this solid expansion. So this is called bimetallic stripe. Let's watch how it's work. In bimetallic stripe there are two metals. One side there is a brass metal here. This is brass, and the other side that is steel. Two metals well riveted in that one. And though that bimetallic strip we will fix here to the stand. Now you can see this. There is the level, or there is a line with the scale. You can see this one. And now we will heat this up. You can see the line like that. Then we are going to heat this up. First light up the Bunsen burner. Let's light this up. Yes. Then let's observe what happens here. Slowly the bimetallic stripe, it's bending upwards. Yes. As it is heated up here, it's bent upwards. It's because there is a metal, the metal at the bottom, it is expanding more. That is the brass metal. Brass metal expand at a higher rate than the steel. Now extinguish the Bunsen burner. Let's see what happens back. Can you see this is straightened up again? It was bent, now it is straightened up. So this is the action of bimetallic stripe. There were two metals, and the brass, it was expanded more, and steel here it expanded less. That's why it was bent upwards. That is the explanation for the bimetallic stripe. Now we'll move on to the applications of this expansion, solid expansion. This is one application. If a bottle lid is tightened up, or if it is difficult to lose, you can put some warm water over this. When warm water is pouring over that, the lid expands, then easily we can remove it. We should not keep it warming long time. If glass bottle also expanded, that will not work. So we have to use some warm water to expand the lid, then easy to remove. Next application is this. In electric irons we use this one, this device, it is the bimetallic stripe. Using bimetallic stripes, when this electric iron is heated up, automatically disconnect. And this switch is a thermostat switch. That is the second application of solid expansion. Third application of solid expansion is this. Normally when put in concrete roads, or the maybe the buildings or somewhere, it's very important to keep this type of gaps. If we don't keep such gaps, this will happen. The concrete will crack. It's because in daytime when this floor is heating up, it can be expanded. If there is no space to expand, the floor can be cracked out like this. Next, this application. In a hot day, railway roads can be bent like this in very hot days. If we use single rail like this, but there is a tactic to prevent it. The tactic is this: keeping gaps between rails. When the rails expanding, then there is a gap. Therefore, the space will fill, and night time or early morning you can see the gap, but in daytime this will be closed. So we can prevent bending of the rods in hot days by keeping this type of gaps. Third application is that. Next application is this. Look at these cables. Early morning we can see the cables, they just look like very straight because they have been contracted, but in the daytime or the midday time you can see they just looks like hanging down, bending. And this is also due to the solid expansion. In daytime it's hot and solid expand and the cables bending like this. So these are the applications of solid expansion. Our next chapter is the liquid expansion. Again there is an activity. Let's see the activity. For this activity we will use these things, and we need a glass bottle with a rubber lid. Also to that rubber lid I have fixed a plastic tube here. It's a pen tube, normal pen tube. And also some colored water we need. Here you can see colored water and 2 empty beakers. We'll start the activity. This is warm water. In warm water we will use the warm water later on, and cold water also we will use. Now first we fill some colored water to this bottle, and that is not enough. Let's fill some more colored water like this, filling colored water to the bottle. Then we can fix the rubber lid with the tube. Fixing it slowly. Right, now there is an initial level of the liquid. You can see this. Thereafter we will put it in one beaker, inside one beaker. Now we pour warm water to this. Pouring warm water. Right, here we are pouring warm water, and observe this level now. When you observe, you will notice, can you see the water level runs up? Water level goes up like this. The water level goes up because of when warm water heat up this liquid, the liquid expands. That's why it's go up. And then you can notice it's remain that level. We will take the bottle out from this beaker. Hereafter we will keep it back on the other beaker. Now we pour cold water to this. Pouring cold water like that. This time we will notice the reduction of the level of tube. The water level will go down. If you notice it carefully, it's slowly going down. So that's the contraction. The previous occasion it was expanded. Now this is contracting. So liquids also expand. That's the final conclusion of this activity. Now let's move on to the applications of liquid expansion. If you think about the previous experiment, similar application is seen in these ones. There is a liquid in this bulb. When it is heating up, the liquid runs through tiny capillary tube here. These are thermometers, liquid in glass thermometers. That is the first application of liquid expansion. There is another application here. This one is called drinking duck, and this is a toy actually. Normally when the water cools down here, then it contracts and water fills back to this, then the duck comes up, or the duck moves up here. Again, when it is heating up, again the liquid goes up into the head and duck moves down. This toy is called drinking duck. It's an application of liquid expansion. Activity number 4 in the page number 4, this is the gas expansion. Here are the things needed. Let's watch this activity. Activity number 4 in page number. Right, what are the things we need? We need a glass bottle and with a balloon here, the glass bottle with a balloon, and a beaker, empty beaker, and warm water. So the activity will start like this. Keep in the bottle inside the beaker. Then we pour some warm water to the bottle to heat up the gas inside the bottle. There is only one thing inside the bottle, that is gas. Now notice the balloon is slowly getting bigger. So we can conclude, when we pour warm water, gas inside this expand, its volume increasing, therefore the size of the balloon increase up. And we must wait till it expands or it gets bigger. Let's wait till it gets bigger. I think we must pour some warm water to warm the bottle more. Pouring warm water over the wall of the bottle, and let's play it little bit fast forward here. And pouring warm water continuously. So the balloon now rising up, you can see its size increasing. And when pouring some more water to this, yes, balloon straighten up now. This is because the expansion of gas inside the bottle, and gas expand and fills into the balloon here. Final few touch, yes, it was fully blown up. Now we will take this bottle out from the hot water bath. Then we will keep it outside. Look at this. Taking the bottle out and keeping it freely outside, and let the bottle to cool down. So bottle is now cooling down. Again the gas inside that cooled down, it will contract here. Let's wait and see. Takes little more time to cool this down. Now you can see, observe the balloon. Always keep eye on the balloon. Yes, it was contracted. This is the demonstration of gas expansion. Gases expand when they are heated up, and gases contract when they are cooled down. Are there any applications of this gas expansion? Let's find them out. There is an activity. This activity shows us a kind of application of gas expansion. This is a simple experiment. You also can do this at your home. Try it out. Take a coin and keep that coin over a glass bottle. Remember, you must wet the surface of the mouth of this bottle and wet this coin. Wet coin you have to keep over that and tightly hold the bottle. You will notice this coin jump up and down. And what is the reason for this? Reason is when we heat it up, when we hold the bottle by our hand, the air inside the bottle heat up. As the bottle heat up, then the gas expand. That expanded gas, or the gases which has high volume, leave out from the mouth by lifting the coin up. That's how it's work. So this activity you can try out at home. That is an application of gas expansion. What are the other applications? This application, when these air balloons or hot air balloons, they are running with the expansion, because hot air is filled in that. The hot air expands and the balloon's density decreases and they rise up in the air. The other application is this. In daytime, if you hold a bunch of balloons like this in open area, when sunlight falls on these ones, if sunlight falls on that continuously, what tend to happen here? These balloons will burst out. You can just understand the reason for it. Reason is when sunlight falling on that, they are heating up. Then the balloon gets bigger. Finally, it bursts out. So in some functions or festivals, you might have seen balloons blown up at outside, but in daytime normally they burst in because of this reason. That is the second application of the gas expansion. With that, we will finish our lesson today. You can read the note from www.itssciTimeblogspot.com from our blog site. Also copy down the note to the tute. And our next lesson will be the last lesson of this lesson, means this unit, change of states of matter and the effects of heat to the environment. Then if you enjoy this video or learn something from this video, just press the like button, and also to get new lessons, subscribe our channel, YouTube channel, and to get the notifications you can press the bell icon as well. So we will meet back from the next lesson. Goodbye everybody.